So what we talked about last day was voltage. We gave you some definitions. We talked about charge is measured in coulombs. Kiana, 1 coulomb of charge would probably fry you it would kill you if you absorbed it all at once. Having said that, one of these batteries actually contains probably about 2,000 coulombs of charge. It's just there's no way it's going to discharge it all at once, which is why it's pretty safe. Potential is the ability to do something. Energy is the ability to do work. So we said potential energy is stored energy. It means that if an object has potential energy, if you use it right, you can get it to do some work. Electrical potential energy we talked about. And we talked about electrical chemical cell. By the way, a battery is technically a series of cells, but we're going to use them probably interchangeably because I'm not that fussy. So we tried to talk about voltage. We said that voltage was sort of like height. We said that if you separate charges, they want to fall back towards each other because unlike charges attract. Very similar to if you lift an object up, if I let this go, which way does this tennis ball, which way does it want to move? Down. It has energy, it wants to move back down to the earth. Voltage is, if an object has voltage, it's sort of like you've raised the charges to a height. And I keep saying sort of like, because it's really nothing like, but it's sort of like you've raised the objects to a height. And if you let them go, they'll want to fall back down towards each other. But we're clever. We can force them to go in the path that we want and bleed off some of that energy. Talking about batteries, so every battery has terminals. Big square batteries usually have the terminals like little springs. Smaller batteries, that's the positive terminal, and the negative terminal is on there, although we said actually it doesn't quite look like that. We talked a little bit about a circuit. So we repeated ourselves. We talked about electric potential energy and then voltage. I said voltage is how much energy every coulomb of charge has. In fact, 1 volt is 1 joule per coulomb, for what it's worth. 1 joule of energy per coulomb. It's also called potential difference. How do we measure it? I'm going to teach you how to use a voltmeter today. We measure voltage with a voltmeter. By the way, the word meter is a Latin word, a Greek word. It literally means measure, so voltmeter means voltage measurer. Oh, by the way, what else did we notice? What was the voltage in this thing here? Do you remember what it was? Amelia, you're right. 1.5. What about this smaller battery? 1.5 volts. What about this even smaller battery? Also 1.5 volts. So what was the difference then? This bigger battery has more electrons. It'll last longer. It can't power a bigger device, but it'll last longer. Why do we want to go to smaller batteries? Because we're in the miniaturization age. So we're trying to find ways to cram more charges into a smaller size. But these don't run different devices. Oh, the exception, of course, these square ones, these are the 9-volt batteries, so they're different. So we said a small battery has the least amount of energy. It can power the same device. It won't last very long. Big battery has the most energy, powers the same device, but it'll last longer. It's got more energy to slowly bleed off. I showed you the laptop fire video. And then what we're going to talk about today is how a chemical battery works. In fact, the second half of today, you're going to build a battery. To make a battery, what you need are 2 different types of metal. Electrodes is the fancy term. Because, Kevin, if you have 2 different types of metal, one of them will want electrons more than the other one. It has a higher electron affinity, if you want the fancy word. Now, if you just touch 2 metals together, you won't get necessarily a voltage. You need to make it easier for the electrons to travel. And so what we have is an electrolyte. This allows electrons to flow between them. Every battery has 2 electrodes and some kind of electrolyte between them. Usually the electrolyte is some kind of an acid or alkaline paste in a dry battery. In a wet battery, in a wet cell, the electrolyte is a fluid, sometimes water. Now there's some kind of, they get more complicated. We watched a video, how do batteries work? We watched a video, how to make a lemon battery. And this is where we left off, so you can pick your pencils up. I think we said this, okay? Chemical reactions, you have this picture, yes? So suppose you put a copper electrode and the zinc electrode in to a beaker. Are those two different kinds of metal? Oh, what do you guys, you need to fill your, okay, you're filling in words. All right, let's do this. Because I underline what you're supposed to fill in, don't I? So chemical reactions take place that, okay, we are going to remove electrons from the copper strip. Zinc wants the electrons more than copper does. That leaves the copper with a positive charge. At the same time, it turns out you're actually removing atoms from the zinc electrode, leaving the electrons, removing protons, leaving the electrons behind, which means the zinc is going to be negative. Now, the problem with this is this will erode, this will decay, this will wear out. That's what happens. If you ever take apart a dead battery, you're going to notice it looks all weird and powdery. It's because you've done a chemical reaction and you've eroded one of the electrodes. What you need to get the electrons to flow from here and the protons to flow from here is some kind of electrolyte or acid solution. In fact, I showed you the video of how to make a lemon battery last class. This creates what we call a potential difference. Who remembers what's another word for potential difference? This is important. Okay? Also called voltage. The reason we call it a potential difference, Kiana, has to do with my analogy of saying voltage is like height. What we're saying is there's a difference in potential energy levels between the two sections, and so you can get charges to flow from one area to the other. And if they want to flow, we can bleed off some of that energy. Put your pencils down. We have everything in place to have an electric, fairly pollution-free society. Lena, we can build electric cars. In fact, the Tesla Roadster, which is one of the more advanced electric cars, the motor in there was invented by Nikola Tesla in 1890. That technology we've had for ages. The big issue is battery technology. We're waiting for the breakthrough. So keep an eye out, and if you suddenly hear, hey, we can store lots of energy cleanly in batteries for a long time, probably your generation will be the generation where gasoline-powered cars become like the old-fashioned cars that you occasionally see on the road. Quaint, but not necessary anymore. What's your homework? Well, first of all, I said we're going to answer orally. You ready? Questions for us to answer. What device uses chemical energy to give charges electric potential energy? Begins with the letter B. Battery, or an electrochemical cell. What's the definition of energy? Do you remember? I said it was the ability to do. Go look at your notes. Somewhere there's the word energy in there. Energy is the ability to do work. We talked about kinetic energy and potential energy. Do you remember the differences? Kinetic energy was the energy of anything that moved. Potential energy was stored energy. This one is important. Number 4, what's another word for electric potential difference? What two factors determine the energy that the charge possesses? You know what? I can't remember what I was getting at there, so I'm going to say skip. What's the purpose of a voltmeter? Measures voltage. And you should know what are two groups of batteries. We have what we call dry cells. These ones. And car batteries are a classic example of a wet cell. So a car battery, for example, you can't tip it. This, I can do that, but a car battery you want to keep upright. Yep.
Do you have a car battery?
Well, cars do. Do I have one here?
Like in the auto shop, right?
Oh, they would, I'm sure. They're heavy, so I don't want to lug one around. They weigh about probably 40 pounds, 30 pounds. Cross that out. Okay. I'm going to be giving you an assignment, but then we're going to be doing a couple of labs, and you'll have time to work on the assignment later on in class.